Hi, my name is Basinger. I'm an assistant professor here at the University of Georgia. Today we're here in Watkinsville, Georgia at the J. Phil Campbell Research and Education Center. I want to talk to you all today about some work that we have going on here at the University of Georgia. It's what's called Living Mulch. So what we have here today behind me is one of our semi-long-term studies. So this study's been going on for about, this will be the fourth year of this year in 2023. And so we have these four different treatments. As I mentioned before, cereal rye. We've got the Living Mulch, which is a white clover released from the University of Georgia called Durana, crimson clover, as well as, like I said, the bare ground system. And so the goal of this project is to look at several different things. The first thing that we are trying to look at is how do these different cover crops work in a cotton production system. And so, you know, out of these 12 different rows, we've got some subplots that we're looking specifically at yield. And then we have other subplots that we're looking at Palmer amaranth demographics. So, you know, how our Palmer amaranth populations advancing over time, what type of seed production are we seeing, biomass growth, and then we also have a small seed burial study in here to look at the effect of different cover crop treatments on weed seed degradation at different depths. And one of the things that we've realized that we have to do is that we have to establish what's called a vegetation-free strip. So if you look here in this strip right here, you can see that about 10 days ago we applied a Roundup in this strip, right? So we're banding that herbicide in the strip. This strip is approximately 10 inches wide, the width necessary for that strip to be established so that we minimize the competition with the clover during the establishment of the cotton. So one of the benefits of establishing this strip is, as we all know, clover, as with other legumes, fixes atmospheric nitrogen. And so by killing this clover off, it's actually releasing some of that nitrogen for cotton establishment. And as that cotton plant grows, it will actually shade out some of this clover, and the clover will start to die off and continue to release that nitrogen over the course of the season. This is a stoloniferous plant. And so what will happen is over the course of the season, this clover will move back into the planted row and cover the ground where we previously established the strips. The J. Phil Campbell Research Education Center has no history of Palmer amaranth. This has given us a unique opportunity to study Palmer population dynamics over time. So what we've done is we've actually established in the first year of this study some micro plots within these larger plots. So what we did was in the first year we put out about 20,000 seeds per meter, and over the course of time we've counted the emergence of those populations, and then at the end of the season what we've done is we will harvest those, we'll weigh them for biomass, thresh the seeds from the female plants, and then return those seeds to the seed bank to track for the following year. So here we are again. We're looking at a weed seed degradation study run by PhD student Hannah Lindell. She's done a fantastic job with this study, looking at four different weed seed species. So we've got morning glory, we've got Palmer amaranth, we've got broadleaf signal grass, and we've got crabgrass. So the idea behind this study is to basically have an understanding of what are the impacts or the effects of these different cover crop species on weed seed degradation. And so these weed seeds are buried at four different depths. So the idea there is that, you know, we would see variability not only between the cover crops treatments, but also between the burial depths, to look at what are the impacts on weed seed degradation. Since we have a perennial living mulch, we have something green on the soil surface year-round, whereas something like a crimson clover versus our living mulch, and in the case of our cereal rye, we have, you know, very large root systems and things like that that could affect microbes, fire ants predating weed seeds in some of these plots. So what we've seen in those first 2 years is that we saw about a 95 to 98% drop in the amount of emergence that we had for Palmer amaranth, both in the living mulch and the cereal rye compared to this bare ground plot. Our crimson clover also was similar to our bare ground plot. Here in the southeast, because it is so wet and so warm, that crimson clover tends to only last 3 to 4 weeks before it's broken down completely. That being said, we're also seeing a huge drop in the amount of seeds produced, specifically in the cereal rye plots and the living mulch plots in the first 2 years. And we've seen that both of those years. Now, one of the things that we often talk about in integrated weed management is the idea of using multiple tools. And so in this last year and this year for these plots, the goal is to add another tool to the system. And so what that tool is we're going to not only have our living mulch and our cereal rye and crimson clover, but we're also going to be layering herbicide applications on top of that to see if these layered approaches and these multiple tools can continue to change the trajectory of those palmer populations. And so what we saw this last year is that with those broadcast applications, specifically in our cereal rye and our crimson clover and bare ground systems, we were able to reduce the number of palmer amaranth plants that were not only emerging, but also the long-term impacts of those the seeds going back into the soil seed bank. Unfortunately, what we saw with our living mulch, because we only established and maintained that vegetation-free strip, we did have some palmer amaranth come up in between the rows as that clover died back over the course of the summer. So, but the goal is to continue this study long-term, rotating to other crops like corn, soybeans, and look at the long-term impacts of some of those rotations and impacts in the soil seed bank for these different cover crop treatments.